All right, lesson 9.2, L'Hôpital's rule. I believe that's how you pronounce it. I have heard that it's actually was hospital at one point in time, and I have my students pronounce that. So anyway, this is a better way to find limits. What's the limit as x approaches 0? By the way, pay close attention to this. Sometimes it's infinity, sometimes it's 0, sometimes it's this, sometimes it's that. All right, we plug in 0, which is what I always recommend. We get square root of 1 minus 1 over 0, which is 0 over 0. All right, that means, okay, we can use L'Hôpital's rule. Now, how would I find this if I didn't have L'Hôpital's rule? I would probably do a fraction thing where I put the x under here, something like this. This would go to infinity, so this is no good. This wouldn't work. All right, so I'd graph it, all that stuff. Well, let's do L'Hôpital's rule, and it's right down here. I'll go through it in a minute. Basically, we take the derivative of the top, the derivative of the bottom. All right, so d dx square root of 1 plus x minus 1 over d dx of x. I don't think I'll write it out like this again, but the biggest confusion people have is thinking that this is a product quotient rule problem. It's not quotient rule. It's just derivative of the top by itself, derivative of the bottom. Bottom's a piece of cake, 1. Derivative of negative 1 is 0. Square root of 1 plus x is 1 plus x to the 1/2. So d dx of that is 1/2, 1 plus x to the negative 1/2, no chain rule. So we would get 1 over 2 square root of 1 plus x. Now, can we plug in the limit of 0? Yes, we can. We end up with 1/2. I think I might have multiplied this by a conjugate and see what happens. Root 1 plus x plus 1. Blast it out that way. Hopefully we'd get 1/2 that way too. Yeah, that might work. You know what? I don't have any time for this, but let's give it a shot. Root 1 plus x minus 1 over x multiplied by root 1 plus x plus 1 over root 1 plus x plus 1. Top, middle terms drop out. We get 1 plus x minus 1 all over x root 1 plus x plus 1. See ya. Plug in 0, square root of 1 is 1, we get 1/2. Hey, that's pretty cool. It actually worked. Anyway, interesting math. I'll leave it at that. So that's L'Hôpital's rule. When we get 0 over 0, holy cow to people. I got 1 over 0. I'll just L'Hôpital's rule. 1 over 0? No. 1 over 0 is infinity. Done. That's it. All right. Take derivative of the top, derivative of the bottom. Here it is. Not the quotient rule. I don't know why I like writing no on my notes so much. That's it. All right. So first things first, plug in 0. 0 on the bottom, square root of 1. 1 minus 1, see ya. Minus 0 over 2, see ya. All right. So let's rewrite this as 1 plus x to the 1/2, so I know what I'm doing. All right. I actually would strongly recommend writing that out so you don't forget what the heck you're doing. 2x. We just did this one, right? 1 over 2 root 1 plus x. Minus 1 is gone. Minus 1/2. Plug in 0 by, plug in 0. 1/2 minus 1/2, we get 0 over 0. Keep going. 0 over 0 is, the first problem we started with. Nothing's changed. Just do it again. By, this is actually, now let's write it down here. 1/2, 1 plus x to the negative 1/2. And d dx of that is negative 1/4, 1 plus x to the negative 1. That was bad. Brain cramp. Negative 3/2. That was painful. Derivative of the bottom is just 2. Or the top, like we just said, that's gone. Negative 1/4, 1 plus x to the negative 3/2. Still plugging in 0, gone. 1 to who cares? End up with negative 1/8. Negative 1/4 divided by 2 is negative 1/8. Hey, look at that. I got it right. Very cool. All right. Get 0 out of 0. L'Hopital's will get it. Do it again. There's nothing wrong with that. Long time ago, we memorized the limit as x approaches 0 of sine of x over x. So plug in 0. And here's how I would do it. I think I shortcutted it up above. Sine of 0 over 0 is 0 over 0. Then I put my arrow. Limit as x approaches 0, cosine of x over 1, which is 1. So L'Hopital's rule saves us, but please don't just apply it indiscriminately. Remember, 1 over 0, you can't do it, all that good stuff. So here's more examples. Limit as x approaches 0 from the positive side. Well, why would they do that? Because this squares it away. I don't have a good answer for that. All right. That's 0 over 0. So cosine of x over 2x. That's 1 over 0. All right. Here's why the positive side. If I came to 0 from the negative side, it'd go to negative infinity. I'd have to graph it. I'm not going to. So that's infinity. Yeah, I can graph it. I don't know why I'm making a big issue of it. Something over x eventually looks like this. It's the dominant function, cosine of x. Just kind of wiggles around the middle there. So we're on this side. Same thing. But we're coming from the negative here, so we'd get negative infinity. So we're on this side as opposed to that side. No, you'll never have to do that on the test. No, you'll never have to do that on one of my tests. You might. I don't think so. Okay. How about as x approaches pi over 2? Ooh, something that's not 0. Well, that's 1 over cosine of pi over 2, which is 1 over 0, which is infinity, over 1 plus tangent of pi over 2. Right, undefined. Had a brain cramp there, which is basically 1 over 0, which is equals line. That's that line there. Infinity, which is infinity over infinity. Notice I didn't say, and that equals 1. Ooh, that's one of the things we're going to do down here. Hey, we can use it for infinity over infinity. Okay, derivative of secant. Oh, Lord, I don't remember this at all. Yes, I do. Secant x tangent x. And we're still doing the limit as x approaches pi over 2 over derivative of 1 secant squared x. Get rid of one of those. Limit as x approaches pi over 2. Tangent of x over secant of x. That's sine over cosine over 1 over cosine. So we're looking at limit as x approaches pi over 2 of just sine of x, which is 1. That seems awfully complicated to me, but yeah, that's how it works. So, all right, L'Hopital's rule also works for these infinity over infinity, infinity times 0, infinity minus infinity. I want to be very clear. These are not on the AP test. Maybe. I don't think I've seen it, but I don't want to say something I'm not 100% sure of. All right, but you will see them on my test, so not a bad idea. And limit as x goes infinity is infinity over infinity. And this actually gets into something we're going to talk about soon. Which one grows faster, square root of x or ln of x? Turns out square root of x grows faster, so I'm guessing this is going to go to 0. We'll find out. So we still have the same process, 1 over x. This is 2x to the 1/2. 1/2 to x to the negative 1/2. So we get 1 over x to the 1/2, x to the negative 1/2. We can actually do a flippy floppy thing here. I'm going to box this. We're actually going to use the space below it, where we get limit as x approaches infinity, x to the 1/2 over x. 1x divided by that, flip and multiply, which is x to the negative 1/2. Still need that limit as x goes to infinity, which is 1 over square root of x, which is 0. What a mess, huh? Well, that's why you have to do all that algebra before you get to calculus. Now, this one, there's a couple different ways to do it, but we've got infinity times 0 sitting right there. So as limit goes to infinity, 1 over infinity is 0. Sine of 0 is 0. So we get infinity times 0. So what we're going to do is something that's really slick, which I don't like to teach, but you're stuck with it. I'm going to change this limit as x approaches 0. I'll show you a better way to do this another time. And change this part to 1 over x and this part to sine of x. And you're probably like, what just happened? And I was first time I saw it, but let's think about it. If I put an infinity here, I get infinity. If I put infinity here, 1 over infinity is infinity. Pardon me, that's a 0. I don't know why I just did that. That's so weird. 1 over 0 is infinity. Put infinity here, I get sine of 0. Put in 0 here, I get sine of 0. Hey, it works. All right. So that's like saying sine of x over x, limit as x approaches 0. Hey, we've seen this for 1. I don't even have to bother with L'Hopital's rule. We've done it. Okay. So now we have the same exact problem, except we're going to negative infinity. It doesn't matter. It just equals 1. There's no asymptotes like there was up here, where we had to worry about what we're going to infinity. Is it positive or negative infinity? Again, not on the AP test. Yes, on my test. Here's the exact same thing. Nothing's changed. All right. More. Limit as x approaches 1. All right. ln of 1 is 0. So this equals 1 over 0 minus 1 over 0, which you're like, hey, that's 0. And no. Got to be a little more careful of that. So limit, yeah, I'll do limit. Let's go with common denominator and start playing. X minus 1 minus ln of x minus 1, ln of x. Why? Why, Mr. T? I'm lost. Why would you do that? I don't understand. When can I run L'Hopital's rule? When I have 0 over 0 or infinity over infinity. All right, in this case, ln of 0 is negative infinity. Negative infinity. Okay, good. So we can just run with this, but we've got a fraction. So that's okay then. All right, so now I can do L'Hopital's rule. X is 1, gone, minus 1 over x. Oh, I didn't leave myself enough space. Leave it. X minus 1 times 1 over x plus ln of x. Yep. Apologies for making a mess out of this. Before I do this, maybe we can do some algebra on top. Common denominator on top, x minus 1 over x. On the bottom, distribute the 1 over x to get 1 minus 1 over x. Maybe I should go with a fraction. Yeah, I'm not going to distribute it. I'm just going to make this x over x. So it's x minus 1 plus x ln of x all over x. 1 over x is there for this part right here, and then I want x over x here. So these cancel. And I'm still haven't taken my limit as x approaches 1, x minus 1 over, wow, x minus 1 plus x ln of x. Plug in 1. 0 over 0. Well, something else there. Keep going. Limit as x approaches 1. 1. 1 plus ln of x plus 1. Yeah. Plug in 1, 0, 1/2. To apologize, made a real hash of that, but algebra to a fraction, then I can do L'Hopital's rule. To a fraction, then I can do L'Hopital's rule. Off you go. Yeah, I don't know why I kept thinking L of x or something else here. All right, now other cases, 1 to the infinity, 0 to the 0, infinity to 0. Again, we got to make fractions. So that's the bottom line here. We make fractions, we're good to go. All right, x approaches infinity. This is going to give me e. I got something up here. So we're going to do a real neat trick. This would be 1 plus 0 to the infinity, which equals 1 to the infinity, which is no idea. So we say, hey, let's take a natural log. And I'm throwing my limit part out. And throw the x out front. 1 plus 1 over x. At which point you say, okay, I'd like to do L'Hopital's rule, but I don't have a fraction here. So I say, well, let's change this to 1 over x. So limit x approaches infinity. And by the way, we threw a natural log here at the very end. We have to put an e in front of it. Natural log 1 plus 1 over x over 1 over x. Flip up, comes x out front. All right, hey, now we can put in infinity. Hey, it still doesn't work, so we take the derivative top and bottom. One over 1 plus 1 over x times derivative 1 by derivative 1 over x is negative x to the negative second. Derivative the bottom is negative x to the negative second. Sweet. I like that. Okay, plug in infinity. I get 0, ends up with 1. Done? No. All right, remember we threw in this earlier. We have to undo it. So equals e to the 1. We took a natural log. Now we're going to do e equals e. By the way, that's a very common one. You should know that. That's how we find e. Take the limit as x approaches infinity of 1 plus 1 over x to the x. That's compounded an infinite number of times formula. All right. That makes me want to cry, but you know, hey, this is math class. What do you want? This limit as x approaches 0, and we throw on the positive side of x of x, it says, well, let's do that thing where we go ln of x to the x and throw the x out front, and then let's do that thing where we put it 1 over x and plug in 0. Ln of 0 is, I don't know why I'm struggling with ln of 0. It's negative infinity. Weird. And that's a 0 to the 0, which is weird. Over 0, infinity. So yeah, we got a problem. So let's finally do our job here. X approaches 0 from the positive side, 1 over x, negative x to the negative second, which is, limit as x approaches 0, 1 over x squared, flip it up, we end up with, I believe, negative x. Sounds right. Plug in 0, we get 0, not negative 0, just 0. But don't forget, e to the 0 is 1. So the limit as x approaches 0 of x to the x is 1. Look at you, you're doing math. Insane, insane, insane. Hey, here we go again. That would be infinity to the 1 over infinity 0. Weird. Ln it. And the 1 over x comes out front, we get x, which is nice. Limit as x approaches infinity, which we can do calculus 2. Zero done. Now e to the 0 is 1. Always seems to turn out it's either e or 1. So, all right. Hopefully I haven't freaked you out too bad. Hard. Good luck.